Hello and welcome to another tutorial on algebra test. Today we're going to be calculating the DL of f of x equal to exponential x minus 1 over sinus x. And we're calculating the DL of this function au voisinage de 0 à l'ordre 4. So, just like we did in our previous tutorial, in our previous video, we have the division right here, and it's possible for us to carry out the division à la puissance croissante if and only if we have to confirm the condition. I'll write it right here with a red pen. So we basically can't divide directly. You basically can't divide directly without confirming that the denominator is different from 0. In this case, sinus x. We have to be sure that sinus x is different from 0 before we can carry out the division à la puissance croissante. So, for us to be able to carry out this DL of this function, we know the DL of exponential x, we know the DL of sinus x. So we can start from there and then we see where it takes us to. So, the DL of exponential x au voisinage de 0 à l'ordre 4 would be 1 plus x raised to the power of 2 over 2 factorial. Remember, this is one of the basic DLs, so you can just write this down also in your record book. So that from time to time you can get used to it. So to the order of 4, this is petit e, the x raised to the power of 4. We do the same thing for sinus x. Once again, you can place the DL of sinus x in your book, your record book. So the DL of sinus x, which is another basic DL, to the order of 4 is x minus 1 over 3 factorial x raised to the power of 3. But you see that sinus x takes only the odd DL from, okay, yeah, this is going to be clear right here, hopefully. So you see exponential x is 1 plus x raised to the power of 2 over 2 factorial plus x raised to the power of 3 over 3 factorial plus x raised to the power of 4 over 4 factorial. Sorry, so it keeps going, x raised to the power of 5 over 5 factorial plus x raised to the power of 6 over 6 factorial, and so on. We can get the DL of sinus x from exponential x by taking out the odd powers from exponential x. So here we've taken out x. The next thing we take, and we'll be alternating the signs. So we have minus 1 over 3 factorial x raised to the power of 3. The next thing we're going to take is the order of 5. But since we're alternating the signs, here the next has to be positive x raised to the power of 5 over 5 factorial. But because we're going to the order of 4, we can't have that order of 5. So we are going to stop here because the next order is going to give us order of 5, which we are not looking for right now. So we stop here. But we are still going to say x 3 because we are going to the order of 3 right here. So now we know the DL of exponential x and the DL of sinus x. Now they are saying the exponential x minus 1. So if you want to try, you can pause this video and see what exponential x minus 1 would give us. Okay, so exponential x minus 1 would basically be everything right here minus 1. So we have 1 plus x squared over 2 factorial plus x raised to the power of 3 over 3 factorial plus x raised to the power of 4 over 4 factorial plus petit e de x raised to the power of 4. That's everything right here is exponential x, which is this here, minus 1. So this minus 1 can cancel with this positive 1. And so finally, exponential x minus 1 will be equals to x plus x raised to the power of 2 over 2 factorial plus x raised to the power of 3 over 3 factorial plus x raised to the power of 4 over 4 factorial plus petit e de x raised to the power of 4. So finally, our f of x will now be equal to x plus x raised to the power of 2 over 2 factorial plus x raised to the power of 3 over 3 factorial plus x raised to the power of 4 over 4 factorial plus petit e de x raised to the power of 4 all over our dl of sinus x, which is this right here, x minus 1 over 3 factorial x raised to the power of 3 plus petit e the x raised to the power of 3. Now, if you see right here, remember we'll come back here. We say we can't divide directly without confirming that the denominator is different from 0. Here, over-assignage to 0. That is, when we say over-assignage to 0, it means if I put my x to be equal to 0, what will my denominator give me? So if I put my x to be equal to 0, I'm going to be having 0 over 0, which is basically form indeterminate. So we can't carry out any operation with that. But you can see that we can factor out x from the numerator and x from the denominator. If I factor out x from the numerator and x from the denominator, let me see if we can save that part right there. Oh, we won't be able to see it, so I'll just put it in a new sheet. So we'll use this right here. So f of x, if we factor out x, we'll have x, so we have 1 right here, plus since we are factoring out x, we'll be left with x over 2 factorial plus x squared over 3 factorial plus x raised to the power of 3 over 4 factorial plus petit e, the x raised to the power of 3 because we brought out 1x. And factoring out this, we have x 1 minus 1 over 3 factorial x raised to the power of 2 plus petit e, the x raised to the power of 2. So now, oh, I'm sorry, I made a mistake right here. So sinus x, because we're going to the order of 4, we basically have to stop at 4. We have to stop at 4. It's what the question has asked us to do. So with this right here, I can take out my x. So this, we can't be able to make that correction. So right here I will have 3. I'm so sorry about that, because I've removed x from here. So after doing this right here, what are we left with? We're left with 1 plus x over 2 factorial plus x raised to the power of 2 over 3 factorial plus x raised to the power of 3 over 4 factorial plus petit e to x raised to the power of 3. Same thing with the denominator. Now, can we carry out the division à la puissance croissante? Yes, we can. Over-assignage to 0. If I put in 0 here, I'll be left with 1, and 1 is different from 0. So my denominator is different from 0, so I can carry out division à la puissance croissante. But we have a problem. We are asked to go to the voisinage, to go to the order of 4, right? We're asked to go to the order of 4, but we are having to the order of 3 right here, and we've not even started dividing. So now, because we have simplified by factoring out x, we will no longer be finding the order of 4, but instead we are going to be finding the order of 5, because one order is already missing. We've taken out one order and we've reduced it to 3. So this order too has also been reduced to 3, because we've reduced the x, what we had at 4 to 3. So we have to redo this whole process again, but by adding another expression right here, so that it can become to the order of 5. But our final answer is going to be to the order of 4. I'll show us right here. I know it's a bit confusing, but I'm going to break it down right here. So I'll repeat what I said. So we started with the order of 4, right? And we did this whole process, and we factored out. After factoring out x, we got to the order of 3 right here. But we're supposed to, because we factored out this x, we've reduced the order to 3. And so in order to get our order back, because we have to get our final answer in the order of 4, we have to now include another term to replace this factor that we lost from this particular, the final operation we did here. So we are going to add another term. So the DL of exponential x to the order of 5, because we have to add another term to replace what we've lost, is going to be x raised to the power of 5 over 5 factorial. So I use the blue pen right here to make that correction. So instead of having to the order of 4, we're going to now have to the order of 5. We're now going to have to the order of 5. Same thing here. Now we're going to the order of 5 because we're adding one more term. So I'll do it right here. So this will be plus the DL of sinus x to the order of 5, meaning that means we have to take the fifth part. So that's x raised to the power of 5 over 5 factorial. Now instead of having petit e the x raised to the power of 4, this will go out and we'll be having petit e the x raised to the power of 5. So that means everything here will repeat the same thing up until this last place. So here we're having x raised to the power of 5 over 5 factorial, but we're changing this to 5. Here as well, we're going to have x raised to the power of 5 over 5 factorial, changing this to 5. Here everything now keeps changing, so x raised to the power of 5 over 5 factorial to the order of 5. Here as well, you know, our DL of sinus x, which is denominator, is x raised to the power of 5 over 5. So we're having x raised to the power of 5 over 5 factorial plus this. So this will no longer be 4, but it will now be 5. So we'll come here and do the same thing here. Now imagine, since we factored out x from the beginning, right? Okay, so I'll redo this part of the expression again right here. So I'll rewrite what we have here. We have f of x is equal to x plus x squared over 2 factorial plus x raised to the power of 3 over 3 factorial plus x raised to the power of 4 over 4 factorial plus power of 5 over 5 factorial plus 32 to the x raised to the power of 5 all over x minus 1 over 3 factorial x raised to the power of 3 plus x raised to the power of 5 over 5 factorial plus 32 to the x raised to the power of 5. So what we're going to do right here is same thing. We can't divide because over as n to 0, the denominator is 0, the numerator is 0, and so we're having form indeterminate. So we have to factor out x. So if I factor out x, we'll be left with 1 plus x over 2 factorial plus x squared over 3 factorial plus x raised to the power of 3 over 4 factorial plus x raised to the power of 4 over 5 factorial plus 32 to x raised to the power of 4 all over x 1 minus 1 over 3 factorial x raised to the power of 2 plus x raised to the power of 4 over 5 factorial plus 32 to the x raised to the power of 4. So this would cancel this, and so we are left with 1 plus, that's rewriting this expression, x raised to the power of 2 factorial plus x squared over 3 factorial plus x raised to the power of 3 over 4 factorial x raised to the power of 4 over 5 factorial, and we divide it with our denominator. Sorry. Okay, so I didn't realize that I couldn't see that. Sorry. So I'm going to do this in a new page so you can see what we're doing. So now just bring this here so I can explain this part. So right here we can see that now we can actually carry out the division à la puissance croissante because the denominator now is different from 0 over n to 0. Because over n to 0, we'll be left with just 1 because we have to replace x with 0. So now we can carry out the division à la puissance croissante. But before we do that, let's see again that right here we are having factorial. So just like we said in the previous video, the factorial of 5 is 5 times 4 times 3 times 2 times 1, which is 120. The factorial of 4 is 4 times 3 times 2 times 1, which is 24 if you multiply this. And 3 factorial is 3 times 2 times 1, which is 6. We are doing those 3 because that's what we have. And then there is 2 factorial. 2 factorial is 2 times 1, which is 2. So now we can carry out the division à la puissance croissante. So carrying out the division à la puissance croissante, remember the denominator stays right here and the numerator stays here. So I'll do that in red. So this part is for the denominator and right here is for the numerator. So that side is for the denominator and this side is for the numerator. So for the denominator we have 1 minus x squared over 6 plus x raised to the power of 4 over 120. That's replacing the factorial with its original value. and the numerator is 1 plus x over 2 plus x squared over 6 plus x raised to the power of 3 over 24 plus x raised to the power of 4 over 120. So just like we did the other time, we're going to go through those 3 steps to calculate the division à la puissance croissante. So for the division à la puissance croissante, we are going to be going higher, dividing, but then it keeps going higher. Gibberish, right? But we're going to hopefully understand the concept right here. So first step is to divide the first part here with the first part here. So we go 1 over 1, which will give us 1. Second step is to multiply what we've gotten from here with the entire expression from the denominator. So in this case, we are going to have 1 times 1, which will give us 1. So whatever we're getting from the multiplication, we put it to the numerator area. So we're going to have 1 right here. So 1 times minus x squared over 6 is minus x squared over 6. So you notice I'm putting it where it's having the same power. Sorry. So we're having 1 times x raised to the power of 4 over 120. So that's going to give us plus x raised to the power of 4 over 120. The third step is to subtract what we've gotten from this numerator zone, and then we subtract. So 1 minus 1 give us 0. X raised to the power of 2, so this negative should be here, plus it's 1 times minus x squared over 6, which will be minus x squared over 6. I don't know why I kept them too far. Alright, so x over 2 minus, there is nothing here, so we can call it 0, plus x over 2 minus 0 is still plus x over 2, plus x over 2 plus x squared over 6 minus x squared over 6. So that's I'll do it here, x squared over 6 minus that's plus x squared over 6, that's 2x squared over 6. So this will be 1, this will be 3, so we're left with plus x squared over 3. Now the next power is the third power, plus x squared over 20, x raised to the power of 3 over 24 minus, there is no power below with the order of 3, so it's 0, so we can write it back. So we have plus x raised to the power of 3 over 24. Now finally we have x raised to the power of 4 over 120 minus plus x raised to the power of 4 over 120. So that's basically going to give us 0. So we come back again and repeat the first step. And what is our first step? Our first step is taking the first one here, dividing it with the first one from the denominator area, and writing the answer below. So I have x over 2 over 1, so that's going to give me plus x over 2. Now the third step is, the second step is multiplying what we've gotten with the denominator. So I have x over 2 times 1, which will give me x over 2. So next I have x over 2 times minus x squared over 6. So that's going to give me minus x raised to the power of 3 over 12. I'm supposed to put it right here. I got first. Okay, so we'll try and do this, but for bien-écriture, to write it well, to make it more presentable, it's advisable to write them, the powers, together in the same area so you don't get confused. Now we have x over 2 times x raised to the power of 4 over 120. X over 2 times x raised to the power of 4 over 120. Now you see that this will give us x raised to the power of 5. And remember our question, I'll bring it here. So our question says we have to get the answer to the order of 4. So anything that goes after 4 is going to be in our rest. So that means we're not going to add this one. So we're going to stop here. So we'll go look at the third step. The third step is to subtract. And you notice again that when we keep doing this operation, when we subtract the first part, we always get a 0 because we get to have the same expression and the same variables here again. So x over 2 minus x over 2, we get 0. X squared over 3 minus oh, you see now I almost got lost because I put this x raised to the power of 2 with the x raised to the power of 3, which was by mistake. So again, I'd say it's advisable when you're putting the powers, you put them where they are related, not where they are not related. So x over 2 over 3, x raised to the power of 2 over 3 doesn't have any relation brother sister nephew niece for the denominator, so we just write it back. So we have plus x raised to the power of 2 over 3. So now x raised to the power of 3 over 24 minus x raised to the power of 3 over 12. So that's x raised to the power of 3 over 24 minus is plus, so it will be plus x raised to the power of 3 over 12. So we're going to have x raised to the power of 3 over 24 plus x raised to the power of 3 over 12. Let me sure we can see this. Okay. Okay, so this is better. Alright, so to find the common denominator, we can multiply this by 2. Should use a red pen. Multiply this by 2, because like I said, we can't multiply any number and then to give us 12, but instead we can multiply 12 with a number and to give us 24, so we can have the same denominator. I multiply 2 with 12, I'll get 24. Whatever I do to the denominator, I have to do to the numerator as well. So right here we'll be left with the same denominator, which is 24, and then x raised to the power of 3 plus 2 times x to the power of 3, that's 2x raised to the power of 3. That's going to give us 3x raised to the power of 3 over 24. And this here will give me 1, and here will give me 8. 3 and 24 will give me 8, so I'm left with x raised to the power of 3 over 8. So I replace what I have here, x raised to the power of 3 over 8. Remember, we've not stopped because we are going to the order of 4, right? So now we're going to go again. So we're going to do the first step all over again. The first step is x raised to the power of 2 over 3 over 1. So this one right here. So we're going to have x raised to the power of 2 over 3. The second step is to multiply what we've gotten with denominator. So we're going to do the same thing. X raised to the power of 2 over 3 times 1. X raised to the power of 2 over 3 times minus x raised